All right, now in number 6, we have 135 over 180. Part of this, we need to figure that out. Can we ask the calculator to help us to reduce that fraction? Yes, we could. We have 135 divided by 180, and then you hit enter. That turned out to be 0.75, 0.75. Now, indeed, if you write down the decimal number, you should write down the 0 in front of the decimal point. You see the calculator is a little bit lazy, right? You should put down 0.375 like that. Now, but you want to convert it back into fraction because you want to reduce a fraction. So you are going to press Math and select the first one. The first one, you see that is convert to fraction. So hit enter and enter again. It will give you back the 3 over 4. And that's how we reduce the fraction using our calculator. All right, so always nice to double check with your dancing shoes. Make sure you got it right. All right, now let's get back over here. In number 2 and number 6, turn out we got a negative angle, negative degree or negative radian. What's that mean? How come we have a negative? Well, indeed, let's go back to take a look at, where is it? Here? No. Here, okay? We actually define at the very beginning, right? We will have a positive x-axis, we have a pole over there, and then we turn it counterclockwise. Then we will generate an angle formed by the OP and the positive x-axis. This is the terminal side, and this is the initial side, right? And that's the angle. But what about if we turn clockwise instead of counterclockwise? And that is the time we will have the negative angle. Let's say if I go back down here, this is the 0 degree. What about if I continue to go clockwise? You see what happened? The angle is negative 45 degree, and then when it hits the negative y-axis, it becomes negative 90 degree. And if I continue to go all the way to the negative x-axis, what would be the angle? Negative 180 degree, like this, right? So when we have the negative degree or negative radian, that means the pole is turning clockwise. All right? Okay, let us continue. Let's take a look at the unit circle. Well, what would be the unit circle? Well, and we will have the x-axis and y-axis. And this time, we will make the pole, the OP, equals to 1. And once we rotate this OP, and we will generate a circle. And the radius of this circle will always be 1 unit. So this is 1. And then from here to here is also 1. And the arc generates, and the length of this arc is what we call the arc length. Arc length is S. And indeed, from the very beginning, when we define Well, we chop out a slice of pizza. This is 1, and this is 1, and this is the data. As we increase the data, then the arc length is keep increasing. And by the time the arc length becomes 1 unit also, and that is the time when the arc length is equal to 1, and we will call the angle 1 radian. In between what? Arc length. Yeah. Okay. So now, what about if we don't have a 1 radian? Can we figure that out? What is the arc length of any sector? When we have a circle, we have the radius r, and this would be the angle theta, and what would be the arc length? S is equals to what? Well, we know one full circle. What would be the arc length? We will call this a circumference. It's one full circle, right? What would be the C equals to? That would be 2 pi r, or sometimes people call pi d. So now I'm going to take a look at this table. The data, the angle, and the arc length. If we have one full circle, what would be the angle measurement? 2 pi. And what would be the arc length at that time? We have one full circle, so that is the circumference. It would be 2 pi r. And now, but I don't have the 2 pi. I only have the theta. Then what would be the arc length? S. So I set this up as a proportion. Make it like this. Cross multiply, we got the 2 pi s will be equals to 2 pi r theta. My ultimate goal is to get the s by itself. So how can I do that? I divide both sides by 2 pi. So the s will becomes 2 pi r theta divided by 2 pi. So you see that the 2 pi cancel out. So what would be the s equals to? R theta. It's just simply R times the data. But be very careful where the data is in radian. We must measure the angle in radian, not degree. So now we have the S is equals to R data, and where data is in radian. Okay. So let's take a look at an example. Can we find the arc length of a circle of the radius 10 meters with an angle of pi over 6. We are looking for the arc length. So we have S is equals to R times the data. Can we tell what would be the R? R is what? What is the R? R stands for the radius. So what is the radius? 10. What is 10 m? So what's m? What does m stand for? Meters, right? That's the unit. So R is equal to 10. What is the data? It's pi over 6. So that will give us 5 pi over 3. The unit is absolutely important. What is the unit? Meters, right? Because we have a meters over here. Let's try another one. Can we find the length of an arc of a circle with radius 5 centimeter and an angle of 120 degree? So wait a minute. Do I know the, can I go into the formula? Do I know what is the R? R is what? 5 centimeter. Okay, we got R. How about the data? Do we know the data? The data is 120 degree. Is that right? You have to turn it into radian first, because when S equals to R data, take a look at that, right? The data must be in radian, so you cannot use degree. So the first thing you need to do is you need to turn 120 degree into radian. How can I turn something into radian? Very good. The degree, right? Pi over 180 degree. So now the degree cancel out, and then the 0 cancel out, and then 12 over 18. What can go into both? 6 can go into both. So it will becomes 2 pi over 3. If you're not sure, double check with your dancing shoes. Make sure you got that right. Now I can say S is equal to R data. So that would becomes 5 times 2 pi over 3. And so that will give you 10 pi over 3. And what is the unit? The unit is what? Centimeter. Can we find the measure of a rotation in degree? When a point 2 meters from the center of rotation travels 4 meters. So in another word, hey, when a point 2 meters from the center of the rotation, so we have, this is the center, and then we have 2 meters, and there is a point. Keep rotate, right? It could be 1 full circle. We don't know. We don't know how far it traveled. But when it traveled 4 meters, go like that, maybe. Okay? So from here all the way to here, this is 4 meters. And we are asking what would that be in data. So we have a big slide of pizza, and can we tell what would be the angle theta? We have S is equals to R theta. What is the S this time? 4 meters. What is the R this time? That would be 2 meters. And data, do we know? We don't. So we have data. Can we get the data by itself? Sure. We divide both sides by 2. So we have data is equals to 2. So does it mean that we have 2 degrees? Is 2 what? What is the unit here? 2 radian, right? Because the data in this case is always in radian. And now the question asking you, hey, find the measure in degree. So what do you need to do? You need to convert this and make it becomes degree. So you have 2 radians multiply 180 degree divided by pi, right? Or pi radian. We know that we have an invisible radian in the bottom. So now the radian, that unit will cancel out, and we have 2 times 180 over pi. So we can check it out in our dancing shoes, right? We have 2 multiply 180 degree divided by pi. So we press the second caret, enter. So that will becomes 114.591559. So how many decimal places do you want to give? Let's say if I want to give 1 decimal place, so what would be the answer? 114.6. If I want to give 2 decimal places, so what would that be? 114.59. All right. So that would be 114.59 degree. Now, if the question did not say, that would becomes your choice, right? So you make intellectual judgment, right? Should I give 1 decimal place or 2 decimal places? A circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. Express arc length in terms of pi. Then round your answer to 2 decimal places. So this time the question giving you a very clear instruction. We have a circle, and the radius would be 10. From here to here is 10 inches. Right? And now there is a central angle, which is 120 degrees. And the question asking us to find what would be the arc length is equals to what? And we know that the arc length S is equals to R times theta. But can we apply this formula right away? We cannot, because the data got to be in radian. So what we need to do is we need to turn the data, turn the angle into radian first. So we have 120 degree multiply pi over 180 degree. Right? So 120 degree is equal to 120 degrees times pi over 180. So that would give you 2 pi over 3. So now we could say therefore S is equal to R times theta, which is 10 times 2 pi over 3. So that would give you 20 pi over 3. And what is the unit? Inches. Now, the question asking us to express the arc length in terms of pi. So definitely, we need to tell, hey, this would be one of my answer. But are we done? No, and they ask you the second part. Then round your answer to decimal places. So what's that mean? We need to use our dancing shoes. Let's see, 20 pi. Make sure you use the built-in pi. Don't use 3.14. That will not be right. Divided by 3. Hit enter. So how should we answer this time? 20.94. Okay. So that would becomes equals to 20.94 inches. So that is also one of the answer. All right. Okay, now let's take a look at this again. Okay. Now a little bit earlier, we have the animation. We see that, hey, if I rotate this pole all the way to the negative x-axis, what will be the angle? 180 degree. We have a strict angle. But wait a minute, I can also measure this. Well, what happened if the pole move the other direction? When the pole hits the negative x-axis, what is the angle? Negative 180 degree. So does it mean that 180 degree is equal to negative 180 degree? Well, indeed, we call this the coterminal angles. Two angles are coterminal if they are drawn in the standard position and both have the terminal side in the same location. Okay. Two angles are coterminal if they are drawn in the standard position and both have their terminal side in the same location. Now let's take a look at the animation and then we go back to this, right? And see what is a coterminal angle. Let's go, oops, let's go back here. Now we remember, hey, this is the 0 degree. And then if I rotate this pole, go like this, one full rotation, what would that become? 360 degree. But hey, wait a minute. The 360 degree and the 0 degree, they both share the same pole. The pole lands at the same location. So 0 degree and 360 degree is what we call the coterminal angle. Can I continue? Yes, I can continue like this. I have another full rotation. When I have another full rotation, what would that become? This would be 720 degree. So that is also a coterminal angle with the 360 degree and 0 degree. Can I have another rotation? Yes. How many rotation I can have? As many as we like. So we can keep going like this. Right? Well, we can sing a song. The rail on the bus go round and round, round and round, like this. Keep going like this. So how many coterminal angle we can have? Infinity, as many as you like, right? Indeed, you can go the other direction too, right? If you go the other direction, what happened to the angle? It would go negative. It would go negative and then negative 360 degree. All right? So far so good, right? So let's go back to take a look at this. So with any given angle, you can generate as many coterminal angle as you like by simply add or subtract multiples of 360 degree. So now if I want to find the angle coterminal to negative 90 degree. So what could I say? Let's see. I have 90 degree, negative 90 degree, sorry. Negative 90 degree. Hey, I can give another full rotation. So I add 360 degree. So what would that become? What is negative 90 plus 360? 270 degree. So what's that mean? That really means the negative, oops, yeah, the negative 90 degree and 270 degree are coterminal. Sorry. Well, the PowerPoint has a little bit issue, right? Everybody see that clear, right? Now we won't say negative 90 degree equals to 270 degree. We say the negative 90 degree and the 270 degree, they are coterminal, right? Equal and coterminal are two different things. Right? Now, so if we look at the table, right? The negative 90, how do we get the negative 90? We measure this clockwise, right? That is the negative 90 degree. But that could be, the pole will land at the same spot if you measure from this angle, like this. So that will become 270 degree. So far so good, right? So now let's take a look at another animation. Let's say we got the angle here. Let's check over here. This is 75 degree. And then I continue one full rotation. Go like that. Ding. So these two angles are coterminal. So 75 degree and 435 degree are coterminal. Now we should avoid to say they are equal. They are not equal. They are coterminal. One more full rotation, then we would say 75 degree and 795 degree are coterminal. Of course, we can go the other direction too, right? We can go like this. Ding. So 75 degree and negative 285 degree, they are coterminal. All right? Not too bad, right? So now, can we, let's turn to this. Okay, let me have another page. Can we find the coterminal angles of 180 degree? Now we have a lot. We have infinitely many possibility, right? So let's just try out a couple of them. I could have 180 degree plus 360 degree. That will give me 540 degree. I could have one more full rotation. So 180 degree plus 720 degree. So that gives me 900 degree. Or I could have the full rotation the other direction when I move this clockwise. So I minus 360 degree. That gives me negative 180 degree. Or I rotate clockwise, two full rotation. So I would have the negative 540 degree. So now, finally, I can summarize. I can say 180 degree is coterminal with angles negative 540 degree, negative 180 degree, 540 degree, and 900 degree. I put them in order. Okay. It would be nice, don't you think so? You know, put them in order would be nice, right? Yes. This is just an example I show you. You know, the question will tell you how many you need to show, right? Indeed, how many coterminal angles we can have? Infinitely many, right? So now let's take a look at this one. Can we find two positive angles and two negative angles that are coterminal with A positive 45° and B negative pi over 6 degree. No, negative pi over 6. What's the unit? Radian, right? Now, we remember we can always add or subtract 360°. So it's one full rotation. So indeed, we could tell an angle theta is coterminal with angles theta plus 360° n, where n is any integers. Or, you know, for this, if this is in radians, then how are we going to say that? It will be theta plus 2 pi n. But more often, we will write theta plus 2n pi because we like to leave the pi in the back. Okay. All right, now let's try out this problem. Can we find two positive angles and two negative angles that are coterminal with 45° and coterminal with negative pi over 6 radian?